Okay, so here's number 11. First off, I noticed that I'm starting with a power raised to a power. So I've got the 3 raised to a 6. When I have a power raised to a power, I multiply. So this gives me C plus 5 to the 18th. 3 times 6 is 18. From here, people often have the instinct of wanting to distribute this power into the parentheses. But as we talked about, we cannot do this because it is not allowed to distribute a power to addition. So this, believe it or not, is our final answer. For this next one, I always start by distributing, but not distributing, the power to the product. So I want to give the power of 3 to the 4 and to the n to the 4th, giving me a negative out in front times 4 to the 3rd power and n to the 12th, because a power to a power we multiply. 4 times 3 is 12. That's being multiplied by negative 12 n to the 5th. I want to simplify 4 to the 3rd and get a number value for that. 4 to the 3rd is 64. And so from here, I'm going to multiply my coefficients, so 64 and negative 12. That gives me 768. And add my exponents because I'm multiplying like bases. That gives me n to the 17th. And I have to keep the negative out in front, telling me that my whole final answer is negative. Negative 268 n to the 17th. In this problem, I'm going to start by giving the power of 7 to both bases inside my parentheses. But 1 to the 7th, 1 raised to the 7th power, that's just going to be equal to 1. 1 times itself 7 times is 1. So this is really 1 over 5 to the 7th power times 5 to the 17th power. This is really over 1. So when multiplying fractions, I multiply straight across the top. 1 times 5 over 7, or 1 times 5 to the 17th is 5 to the 17th. And straight across the bottom, 5 to the 7th times 1 is 5 to the 7th. Now I have like bases being divided. And again, I want to think that they're almost in a battle. 7 of these are going to cancel with 7 of these, leaving me with a total of 10 5s left. In this problem, again, I want to give the power of 5 to all of my bases. So I want to give it to the power of, or the base of 2, x to the 2nd, y to the 3rd. So I've got 1 over 4x to the 5th times 2 to the 5th, x to the 10th, because I multiply power to a power, 2 times 5 is 10, and 3 times 5 is 15. I'm going to simplify 2 to the 5th to give me a number. So I've got 1 over 4x to the 5th. 2 to the 5th is 32. X to the 10th, y to the 15th. I always like to try to cancel on the diagonals before I start in on multiplying these two together. So if I look on this diagonal, I have 4 and 32. 4 goes into 4 once. 4 goes into 32 8 times. And if I look at my x's and think of them as battling, I have x to the 5th, which goes into x to the 10th and cancels out, leaving 5 x's in the numerator. So what I really have is 1 over 1. So this whole fraction canceled out to give me 1 times 8x to the 5th over y to the 15th. If I multiply this fraction by 1 over 1, it'll essentially give me a final answer of 8x to the 5th, y to the 15th. And then the last one, I'm going to have to give the power into the parentheses for two different problems. So I give the power of 3 into this quotient, giving me negative 6 to the third over x to the third times, if I give the power to the x to the fourth and the 3 and the y to the seventh, I get x to the 20th, 3 to the fifth, y to the 35th. When I simplify negative x to the third and negative 6 to the third and 3 to the fifth, I get negative 216 over x cubed times x to the 20th over 243 y to the 35th. So if I look on my diagonals, x to the third battles with x to the 20th, leaving me with 17. X is in the numerator. And if I look on the diagonals here with negative 216 and negative 243, they both have a factor of 27. So I'm going to divide both by 27. Negative 216 divided by 27 is negative 8. 243 divided by 27 is 9. So I'm left with the fractions negative 8 over 1, because nothing was left down here, times x to the 17th, 9y to the 35th. So if I go straight across the top, negative 8 times x to the 17th is negative 8x to the 17th. And if I go straight across the bottom, 1 times 9 to the 35th is 9y to the 35th, which is my final answer. And that's a 5. And just to leave you with a little pun, I do have to apologize though, because it isn't even remotely funny. Ha 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 ha.